5 degrees Celsius to 40.5 degrees Celsius is 95 seconds. So we want to calculate the specific heat capacity of that material. So we know what is the formula for specific heat capacity. The heat we have just written over here. It is the heat required to change the temperature. So in MCQ also we have seen the formula of that. This is Q is nothing but the heat given to the substance, that is nothing but mass into specific heat capacity into delta T, that is nothing but the change in temperature. So this is nothing but the heat. Q is nothing but the heat given to that substance. We want to calculate what is the specific heat capacity, that is nothing but this small letter C. Okay, so we can use this formula where Q is the heat, that is nothing but the thermal energy. But what is provided, you can see the power is provided. In the question, power is provided. Mass is it there in the question? Yes, 2 kg mass is there. C is nothing but our goal. We need to calculate. This is unknown. Delta T is the change in temperature. We have the change in temperature, that is 19.5 and 40.5. The difference between that is the change in temperature. So basically, what is not given, the heat. It is not given. Instead of that, the power and time are given. So here we can use the formula of power and the time. You know what is the definition? By definition, what is the power? If you recall, the power is what? Power is nothing but the amount of energy given divided by time taken. Okay. The energy per unit time is called as the power. Okay. Here energy is nothing but the heat energy we are going to use. So I have directly used here Q instead of E. Q is nothing but the heat energy. You have to write down separately. Q is nothing but the heat energy. Okay, so I can just rearrange this formula. I can put here Q is nothing but P into T. P into T. If I take this T to the other side, it will be multiplied to this P. So Q will be equal to P into T. Okay, so we'll calculate first what is the Q, and then we can use this formula of the specific heat capacity to find out the C. Okay, so P is what? P is 420 watt. So 420 is given, multiplied by, you can see the 95 seconds. So I have written here 95. So you can calculate it with your calculator. It is coming out around 39 into 39900, that is 39,900. Okay, so our unit is nothing but the joule, because the heat or any energy is measured in joule. So this is our heat. Okay, so first of all, we have calculated now here the heat, so that we can use this formula. Okay, so from the power and time, we calculated first heat or energy, so that we can use this formula. So I can use this formula over here, and I will write this formula again here. We need to write that formula, so I will select this formula as it is. So I will select this formula here. We have to write down this formula again. So I have, instead of writing down, I have selected here. So we need to find out the C value. Okay, C is nothing but the specific heat capacity. So we have to rearrange this formula again. So I will write down C, small letter C is nothing but equal to Q. Okay, if you rearrange this, will become Q divided by M, that is small letter M, multiplied by delta T. So I can write down here delta T. This is delta T. Now I can put here values for Q, M and delta T. Q is nothing but, we have just found 39,900. So I will put here 39,900 divided by the mass of the aluminum, that is given 2 kg over here. So 2 multiplied by, this is the delta T, that is the change in the temperature. So I'll put the values of the change in temperature, that is nothing but the final temperature minus initial temperature. So final temperature is how much? That is 40.5 degrees Celsius minus initial temperature, that is nothing but 19.5 degrees Celsius. So 19.5 degrees Celsius. Okay, so these are our values, and I can put here again 39,900 divided by 2 multiplied by, how much is 40.5 minus 19.5, that is coming out to be 21. So finally you can calculate 39,900 divided by 2 into 21. So you can have the value is coming out about 950 joule. Okay, 950 joule divided by the unit of the specific heat capacity is this joule divided by kg degree Celsius. So this unit is very specific. You have to remember this unit, degree Celsius. So this thing you have to take care very well. The unit of the specific heat capacity is what? Joule by kg by degree Celsius. Okay, you can directly use this formula. This, what is Q? Q is nothing but joule. What is mass? Mass is nothing but kg. What is change in temperature? That is nothing but degree Celsius. So unit is joule divided by kg into degree Celsius. So joule by kg into degree Celsius, that is nothing but unit. 950 is our value for the specific heat capacity. Here we have to put the value again. So I'm putting over here again 950 joule divided by, I will put here kg into degree Celsius. So I hope you understood this problem. We have firstly used the formula of the power, so that we will get the heat or energy. Once we get the heat, we use this formula of the specific heat capacity to calculate the specific heat capacity, that is the, this is nothing but amount of heat given to the substance, that is given in terms of the specific heat capacity. Okay, so now we'll see the part C of the question. In the experiment in B, no attempt is made to prevent the loss of the thermal energy from the surface of the block. Suggest 2 actions the student would take to reduce the loss of the thermal energy from the surface of the block. So while we are doing this experiment, okay, and we are recording the temperatures of this, and we are doing this experiment without any proper precaution of the insulation. So heat can be lost. This whatever heat we are taking over here, 39,900. The actual heat can be more than this, because heat can be lost to the surroundings, and our answer of specific velocity, specific heat capacity wouldn't be correct, because if you take the incorrect inputs, our answer cannot be correct. So we have to reduce that heat loss to anything, any surrounding or anything. Then we have to take some precaution. What kind of precautions we can take? We can put here, we can put the insulation around the block. Okay, around the block, to reduce that heat loss, we can put the plastic or any other material which can prevent the heat loss. Also, we can do one thing, we can polish the surface of the block. That way also we can do polish the surface of the block. These are not only 2 things that we can do so many other things. We can reduce the initial temperature of the block, okay, or we can raise the temperature of the room, or we can reduce the draughts. Okay, so many things we can do. These are one of them. We can put the insulation, or we can polish the surface of the block, so that heat loss can be reduced, and so that we will get the better inputs to find out the better value of the specific heat capacity. Now we will see the second problem. The question number 2 here you can see in figure 4.1 shows the device used as a thermocouple